Hi, in this video, we'll learn how to create this type of scissor gate, which is expandable according to your requirements. You can move it wherever you want and rotate it without any issues. You can even resize it after rotating. Let's dive into the video. By the way, you can download this file. The link is in the description below. First of all, we need to check the unit setup. In my case, I'm using decimal inches. The unit scale is set so that 1 unit equals 1 inch. Now we need to think about what we're going to create and how to start. First, we create the strips. The space from here to here is 8 inches horizontally, and it is 16 inches vertically. So, we need to calculate the actual length of a single stick, or you could say a crossbar. According to the Pythagorean theorem, the length c is equal to the square root of a squared plus b squared. Here, a is 8 and b is 16. So 8 squared is 64 and 16 squared is 256. Now add them together. 64 plus 256 equals 320. Finally, take the square root of 320, which gives us approximately 17.89 inches. So we'll round it to 17.9. Now we'll create a box from the Create tab. Then go to the Modify tab and resize the box. The box length is 1 inch. The width is 17.9 inches and the height is 0.125 inches. Bring it to the origin 0, 0, 0. Now, we need to find the angle of the strip. To calculate the angle, we can form a right angle triangle and apply the tangent function. According to trigonometry, the tangent of angle theta is equal to the opposite side divided by the adjacent side. That means tangent theta equals 16 divided by 8. So, theta equals the arctangent of 16 divided by 8. 16 divided by 8 is 2, so theta equals arctangent of 2, which is approximately 63 degrees, I think. Let's check it. Arctangent of 2, it's a little bit higher, but we round it to 63 degrees. Right-click on the Angle Snap tool and set the snap angle to 127 degrees. We have to subtract this angle from 180 degrees because we need the angle that's marked with a question. Now, rotate the strip and mirror it along the x-axis as a copy. Now we will make this bolt. Create a cone from the Create tab. Set radius 1 to 0.3 and radius 2 to 0.2. Set the sides to 8 and no height segments are needed. Bring the cone to the origin. Now align it to the strip. And mirror it along the y-axis as a copy. Let's create the vertical bar. Set the depth to 0.125, the width to 1 inch, and the height doesn't matter for now. Again, bring it to the origin and arrange it properly. Perfect. Now make a copy of the bolt for the other side. Next, convert it to an editable poly so we can attach all the elements. Attach the bolt and crossbars to the strip. Don't forget to set the pivot point to the center of the object. Convert the bolt to an editable poly. Attach it and bring the object to the origin. Now let's make the frame. Create a box with a rough size. I'm using 5 feet in height and 5 feet in width. The depth can be around 1 inch, which should be good enough. Bring the box to the origin. Convert it to an editable poly. Click on Polygon mode and select a face. Use Inset and set the value to 1 inch. Hold the Shift key and drag the face backward to create thickness. Now press 2 to switch to edge mode. Click on ring. It will select the inner corner edges. Click connect and create two edges. Adjust the spacing between those edges as needed. Delete the two center faces. Then select the side faces and extrude them by 1 inch. Now let's create a dummy so you can move all the elements together using a single control. Create two reference lines, one for horizontal and one for vertical alignment. Select all the elements and link them to the dummy. Let's also rename everything to make it easier to understand later. By the way, I noticed that vertical was previously spelled wrong. I didn't focus on it earlier since it wasn't important. Finally, attach both the frame box and its vertical bar together. Here, the frame pivot point is at the bottom center. We need to move it to the corner. Create a dummy delegate and move it to the top left corner. Copy this dummy and move it to the bottom right corner, then rotate it. Lock all the axes except the y-axis, so it can only move along the y-axis. Do the same for the other one. Now, select the right side vertex of the horizontal reference line and apply a link XForm to the dummy. Select all the vertices on this side and apply the same link XForm to the same dummy. To fix any alignment problem, go to Vertex mode, turn on Show End Result, and position it correctly. Repeat the same process for the other side. When you move the dummy, the frame will also move with it. Now, you can resize the frame to any size you want. Oh, here is a small mistake. Let me fix it first. Perfect. Now it's correct. Let's edit the vertical bars. We will make an array distribution along a spline. Pick the horizontal reference line and rotate it. By the way, we haven't saved the file yet. Let's save it now. In our project, when we expand the size, the vertical bars should automatically add one by one. And when we reduce the size, they should be removed one by one. But here, they are not adding or removing automatically. So we need to update the count according to the length. We can calculate the count by dividing the length by the spacing. That means length divided by spacing equals count. We need to make a float script. Ceil of length divided by spacing. Now, we must define what is spacing and what is length. Make a variable named spacing. The spacing between two vertical bars is 4 inches, and each bar is 1 inch wide. That means the spacing will be 5 inches. To define the length, make a variable named length. And set it to the curve length of a spline. We have to indicate which spline. So get node by name. Line 1. Now, evaluate the script and you'll see the result. By the way, we can shorten the spline if we move this point here. We can delete that segment and evaluate again. The effect stays the same. We will link the top vertex using link XForm. There is a displacement issue. Let's fix it the same way we did earlier. Alright, it's fixed. Do the same thing for the strips. Copy the array modifier and paste it here. Remove rotation. We need another array for the vertical count. Distribute this one according to the y-axis. Pick the vertical reference line and change the script to line 2. Remove rotation for this one as well and adjust the spacing. Reposition it properly. Now, here is another problem. The strips also appear outside of the frame. We don't want that. We can try to fix it by reducing the percentage, but the problem still isn't fully solved. They are no longer aligning with the frame correctly. We also need to update the percentage dynamically. Let's define this mathematically. Let the full length of the reference line, L, the strip length is 10 inches, call this D. We need a new length called L prime. L prime equals L minus D. So, percentage equals L prime divided by L, which is L minus D divided by L, that equals 1 minus D divided by L. Here, D equals 10 inches. Now, CL of 1 minus D divided by L multiplied by 100 will give the percentage. We already know D is 10. Let's define L. Set it to the curve length of the spline by using getNode by name line 001. Done. Copy the array modifier and paste it onto the vertical bars. Fix the position. Do the same for the upper part of the strips. Alright, now you have learned how to create a resizable scissor gate. We still have to link these two dummies to the parent dummy. Now, you can move it wherever you want, rotate it to any angle without problems, and even resize it after rotating. In my final version, I have added this middle bar with its lock system, the handle, and other necessary elements. I also added the side strips. Here, you can see the final version. That's it for this tutorial on creating a fully resizable scissor gate in 3ds Max. I hope you found this helpful and learned some useful techniques along the way. And if you want to practice, the download link for the final 3ds Max file is in the description below. Thank you for watching, and maybe I'll see you in the next tutorial.